Greetings, math fans. All right, so today's topic is called partial fractions. All right, so here's the deal, math fans. If I give you two rational expressions, like 2 over x plus 3 over x plus 2, and I ask you to combine them, so I want you to combine them. What do you do? Well, don't you get a common denominator? All right, so it means our common denominator, of course, is x times x plus 2. So I'm going to multiply this one by x over x, and this one by x plus 2 over x plus 2. Okay? And then we have one denominator, which is x times x plus 2, right? And I distribute that 2, so I get 2 times x is 2x, 2 times 2 is 4, and plus 3x. And then I simplify that one to 5x plus 4 over x times x plus 2. Right? That's pretty easy, right? But here's the deal. This is the hard part. What happens if I give you this and I ask you to convert that into what we call partial fractions to actually split it up? So this is given, and I want you to split up the fraction. So you're going to have something over x plus or minus whatever, something over x plus 2, which obviously we're trying to get this 2 over x plus 3 over x plus 2. That's actually pretty hard when you think about it. If you're given that, and then you have to try to break it up, I mean, how do you know what x goes with what? All right? Well, let's do the problem. So again, you're going to be given, well, we'll kind of just go down here a little bit. You're given 5x plus 4 over x times x plus 2. And here's the deal. I know it's going to be something, we'll call it a over x, plus b over x plus 2. Okay, that's kind of what it's going to look like. And we got to figure out what that a and what the b are. Well, here's the deal. I want to be able to add that a over x plus b over x plus 2. I want to add them together. So let's get a common denominator. And you guys agree I'm going to multiply this by x plus 2 over x plus 2. And this by x over x. Okay? So here's the deal, math fans. I have the same denominator here, right? Here's x plus 2, x plus 2, and x plus 2. And so what I can do is I can also set that numerator equal to that. So I can say this is going to be 5x plus 4. 5x plus 4 equals a times x plus 2 plus b times x. All right? Now, here's the deal. I need to pick a value. So I need to pick an x value that will cancel a or b. Well, so let's start with a. So do you guys agree if I pick for this, if I say x equals -2, that would put a 0 in for that? So that's what we're going to do. We're going to say x equals -2, and then we're going to plug a -2 into the whole thing. So we got this whole thing. We need to plug x equals -2. So it's basically 5 times -2 plus 4 equals a, and then it's -2 plus 2 plus b times -2. Okay, so wherever you see an x, we plugged in. And so we're going to get -10 plus 4 is -6. This goes away because it's 0, so it's equal to -2b. Divide by -2, and we get b is equal to 3. Interesting. Let's just go back up here. B is equal to 3. Oh, look at that. That is very exciting. Okay? I got a 3 already right there. Okay, so let's keep going. Okay, let's find A now. And how do I cancel? I want to cancel out B, so I'm going to pick 0 for B. So x equals, or 0 for x to cancel the B out. So I get 5 times 0 plus 4 equals A, and then 0 plus 2 plus B times 0. So again, that's out of there, and I wind up getting 4 equals 2A. Divide by 2, A is equal to 2. So again, if we go up to the top here, let's go back up here. Ah, look at that. Right there, math fans. Okay, there it is. There's 2 right there. Okay, so we can basically, let's write our answer now. Let's go down here again. I can write it as 2 over, right, it was A over x, so it's 2 over x plus 3 over x plus 2. And that's it. That's a partial fraction. It's broken up into what we originally got. Okay? So I got a couple more examples I want to do with you guys. It's pretty easy. Let's clear this out of here. And let's start out with 2x minus 3 over x squared minus 3x minus 10. Well, what's the first thing I have to do? I got to factor the bottom because I need to have something to kind of split it up to, right? So if I split it up, I get 2x minus 3 on top, and I get x minus 5, x plus 2. So you know that's got to be equal to a over x minus 5 plus b over x plus 2. Some people are saying, well, how do you know it's plus? Well, if b is negative, then it's going to be minus, so not a big deal, right? So, of course, let's get our common denominator here. So we're going to multiply this one by x plus 2 over x plus 2, and this by x minus 5 over x minus 5. Okay, so what we have is, again, the numerators is what we're going to have to set equal. The denominators are already equal because we have x minus 5, x plus 2. So we wind up getting 2x minus 3 equals a times x plus 2 plus b times x minus 5. Okay, so what do you want to eliminate? Let's eliminate the a first. And truly what we get to plug into there is you have to plug in x equals negative 2, right? So when x equals negative 2, we get 2 times negative 2 minus 3 equals, and again, I'm just going to cancel. That's 0 here, right? So we're just going to have b times negative 2 minus 5. So we get negative 4 minus 3 is negative 7 equals negative 7b. Divide by negative 7, b is 1. Okay, let's do x is equal to, we want to get rid of the b, so we need x equal to 5. So we're going to go 2 times 5 minus 3 equals a times 5 plus 2. Again, the b is canceled out, so we don't have to worry about that. Okay, so we get 10 minus 3 is 7, and we get 7a equals 7, divided by 7, a equals 1. Okay, that's sweet. So here it is. That's kind of what we're putting it in here, right? This guy here. So it's going to be 1 over x minus 5 plus 1 over x plus 2. You got to admit, math fans, that's kind of cool. All right. I mean, we're actually going from something, 2x minus 3, something that who knows what you break it up to, where it comes up nicely, right? It's pretty easy to come up with the partial fractions to break it up. All right, so let's do one more here. In class, I pretty much let the kids pick whatever numerator and whatever denominator they want. Something with it's somewhat linear. A 3. In this case here, we're going to pick 3x plus 2 over 2x plus 1 times 4x minus 3. Okay, so just kind of a random problem. And, let's just set it up like we did before. So it's going to be a over 2x plus 1 plus b over 4x minus 3. And I always leave a space here so I can just multiply it easily. So this one's going to be 4x minus 3 over 4x minus 3. And this is going to be 2x plus 1 over 2x plus 1. Okay? Again, the numerators are the ones we're setting equal. Denominators are already set. So I get 3x plus 2 equals a times 4x minus 3 plus b times 2x plus 1. Okay? Now here's the deal, math fans. This is just a little trickier. But again, I'm trying to pick a value of x to get rid of a. Well, if you want to make it easy on yourselves, just say, oh, that's got to be equal to 0. So set it equal to 0 and figure out what it is. So you get 4x equals 3, so x equals 3/4. Okay, so that's that one. Let's just do this one while we're at it. 2x plus 1 equals 0. So 2x equals -1, so x equals -1/2. Okay, so those are the values we're going to set here. So the first one, we're going to set x equal to 3/4. And, it's just a little nasty fraction action, but not a big deal. So we're going to get 3 times 3/4 plus 2 is equal to, right, the a cancels, so we have b times 2 times 3/4 plus 1. All right, and so, we're going to kind of simplify this. We're going to 9/4, right? 3/1 times 3/4 is 9/4. So we can do a little work here. 9/4 plus 8/4, right, is equal to b times, and this 2 times 3/4, that's a 1, and that's a 2 to cancel some stuff out. So it's really 3/2 plus 2/2. So I get 17/4 is equal to 5/2 b, and then we multiply both sides by 2/5. 2/5. That cancels out to 1 and a 2, and we wind up getting b is equal to 17/10. Okay, so that's our first one, and we can do a just right next to it. So x is going to be equal to -1/2. Get rid of the b here, and so we get 3 times -1/2 plus 2 equals a times 4 times -1/2 minus 3. Okay, and the b's cancel. So 3 times -1/2 is -3/2 plus 4/2 equals a, and this cancels nicely to 2 and a 1, so we actually get -2 minus 3. So that gives us -3/2 plus 4/2 is 1/2 equals -5a, and multiplied by -1/5. And we get a equals -1/10. All right, so my final answer then is -1/10 over, remember a was 2x plus 1, so it's 2x plus 1, and then plus b, which is 17/10 over 4x minus 3. Now, you can't have that, right? You got a complex fraction here. So don't you guys agree this is that -1/10 over 2x plus 1? I can just write that as -1 over 10 times 2x plus 1, right? I mean, if you want to do it this way, you can say that divided by that, or that times the reciprocal. So it's -1/10 times 1 over 2x plus 1, which is -1 over 10 times 2x plus 1. Okay, so same thing with the other one. I can say plus 17 over 10 times 4x minus 3. And that is your final answer, math fans. Okay? Not bad. Now, before I end the video, actually I want to check it. All right? So I've got, if I actually multiply everything out, so let me clear this. Or actually, let's just go, I want to go to the next page here. All right, so let me just rewrite what our answer was here. We have -1 over 10 2x plus 1 and plus 17 over 10 times 4x minus 3. All right, and I want to put these back together again because I want to see if we're going to actually get, remember our starting value? Let me just put our starting thing. Our starting was 3x plus 2 over 2x plus 1 times 4x minus 3. Okay, if I put this together, which is what we created, I should get 3x plus 2 over 2x plus 1, 4x minus 3. I hope. So when I put it together, right, my common denominator is 10 times 2x plus 1, 4x minus 3. So I multiply this one by 4x minus 3, and this one by 2x plus 1. Okay, so if I multiply the top, I get negative 4x plus 3 plus 34x plus 17 all over 10 times 2x plus 1, 4x minus 3. Okay, I combine the top, I get 30x plus 20 over 10, 2x plus 1, 4x minus 3. I can factor 10 out of the 10 out of the top, so I get 10 times 3x plus 2. On the bottom, I get 10 times 2x plus 1, 4x minus 3. Oh, look at that, man. Sweet. And so look what I get. I wind up getting 3x plus 2 over 2x plus 1, 4x minus 3. Okay? So it really does work, but it's so cool. I mean, I'm sorry. I know it's very nerdy of me and everything, but to go from this and to be able to split it up to give you something like negative, like this guy right here, that negative 1 over 10, 2x plus 1 plus 17. I mean, how would you even know that? But partial fractions does that. It's very, very cool. All right? Anyway, that's it, my fans. Have an outstanding day. Adios. Goodbye.